So for years now, AI has been absolutely crushing it in the digital world, right? It's writing code, it's summarizing documents, it's organizing our entire lives. But you know what? That was just the warm-up. We've pretty much conquered software. Now it's time to give our AI agents physical hands. Let's dive into the open source project that is right at the heart of this robotics revolution. And it all starts right here. This hilarious line is actually from the official documentation for a project called OpenClaw. It's a fun little inside joke that honestly hints at a much, much bigger idea. Giving our digital assistants a body, or in this case, a claw. Okay, so what exactly is OpenClaw? Well, think of it as a gateway that you host yourself. It's this bridge that connects chat apps, like Telegram or Slack, to an AI that can use skills to get things done. And believe me, those things are getting seriously impressive. Now, before we get to robots picking stuff up, we've got to understand where OpenClaw came from. And it started as an incredibly powerful brain for your digital life. I mean, just think about what this thing can do. It's like a personal assistant that actually works. It can check you into your flight automatically. You can send it a photo of a recipe, and boom, it adds all the ingredients to your shopping list. It can even summarize your meeting notes and assign the action items. It'll watch a competitor's website for you, or for all you developers out there, it can automate code reviews right on GitHub. It's pretty wild. And this diagram here really shows the key shift. We started with old-school, rigid software. Then we moved to AI in the cloud. But the problem there is latency. Sending huge amounts of data like a video stream back and forth is just too slow. So this new way, with projects like OpenClaw, is all about a locally deployable assistant. All the heavy lifting, like processing what a camera sees, happens right on the device itself. That massive drop in lag is what makes real-time robotics even possible. It's a total game changer. Which, of course, brings us to the big question. What happens when this super smart digital brain wants to interact with the world beyond a keyboard? What happens when it wants to, actually do something physical? This, right here, is the paradigm shift. We're moving from just language to language that actually causes physical action. We are literally giving AI hands. And this slide just lays it out perfectly. The old way to control a robot, you'd have to write hundreds, maybe thousands of lines of really complicated Python code. The new way, you just send your robot a text from your phone, grab the eggplant. It's that simple.
So how on earth is that even possible? Well, the magic behind it is a piece of software called the Claude Bridge. The best way to think about it is like a universal translator. It takes your simple, plain English command and turns it into the complex, low-level instructions that the robot operating system, or ROS2, needs to actually make the robot move.
Okay, so now that we get the how, let's look at the actual hardware that makes it all tick. And this isn't happening on some giant server in the cloud. It's all happening right there, on the robot itself, at the edge. And the hardware setup is actually surprisingly simple. The brain is just a Raspberry Pi 5 running the OpenClaw agent. The eyes? That's a Halo AI accelerator, which is a special chip designed to process what the camera sees incredibly fast, right there on the device. And finally, the hands are the robotic arm that carries out the command. And here's why that Halo chip, the eyes, is so unbelievably important. If you try to run a vision model using just the Raspberry Pi's main processor, you get about 8 frames per second. That's choppy. It's too slow for a robot to interact with the world. But you add that Halo accelerator and look at that jump, almost 77 frames per second. Now that is the speed you need for a robot to see and react smoothly in real time. All right, enough talk. Let's see this thing in action. Here's a simple command given to an Agilex robotic arm that's running this exact setup. And there you go. The robot's camera hones in on the notebook, it focuses on the text, and it correctly reads back AgileX. It's combining vision and language understanding flawlessly. Okay, but can it do something a little more difficult? Let's give it a real physical task. Okay, now watch this part closely. It goes for it, and it misses on the first try. But here's what's so cool. It doesn't just fail and stop. It recognizes the miss, it adjusts its grip, it changes its approach, and it tries again. And on the second attempt, success. This is so much more than just following a script. This is learning from failure in real time. So, this technology is obviously really powerful, and it's moving way beyond just being a project for hobbyists. So, let's zoom out a bit and look at who's actually using this, what's being built, and, well, the very serious responsibilities that come along with it. And yeah, this is no longer just some niche tool.
Almost half of its users are in the enterprise world, building real business applications. The rest are pretty evenly split between research labs that are pushing the limits of science and classrooms that are teaching the next generation of roboticists.
And all this is leading to actual products you can go out and buy today. For around $1,200, an educator or a hobbyist can get a Rossarin Pro rover. On the higher end, for about $16,000, researchers can get a full-on Unitree G1 humanoid robot that works right out of the box with OpenClaw. And for the big companies, NVIDIA even offers an enterprise version called NemoClaw.
I mean, this is all incredibly exciting. It feels like we're living in science fiction, but it really forces us to stop and ask a pretty critical question. With this kind of great power, what else comes with it?
Because this power comes with some very serious risks. There was a security incident called Claw Havoc that was a huge wake-up call, where bad actors use malicious plugins to steal credentials. Then there's the reliability issue. What happens if an AI agent just hallucinates and tells a powerful robot to do something dangerous? And of course, there's physical safety. A bug is no longer just a software crash. It could be a robotic arm causing real-world damage or even hurting someone.
The barrier between a thought, just an idea expressed in plain language, and a physical action in the real world is basically dissolving before our eyes. We've done it. We've given our AI hands. So the only question left for us is, what should we ask it to build first?
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.